Hello everyone, my name is Amanda Woodbury and today I will be teaching you the basics of trigonometry from pre-calculus. This is our new best friend, the unit circle. The radius of the unit circle is always equal to 1. So, any angle can be drawn on this circle, a right triangle can be sketched, and all trigonometric functions of said angle can be found. So the angle theta can be any angle in any quadrant of the circle, as it's shown in the diagram. This circle will also be used for everything in this section. It helps us with all of the functions, the ratios, calculations, everything we learn. This is why it is our new best friend, so try and have it memorized as best as you can. So, when we use the unit circle, we use it to determine the basic trigonometric functions. So, first of all, the sine of an angle is the side opposite the angle divided by the hypotenuse. And the hypotenuse is always the longest side. Nothing is longer than the hypotenuse, which is why it is opposite the biggest angle. The cosine of an angle is the side adjacent to the angle divided by the hypotenuse. And the tangent of an angle is the side opposite divided by the side adjacent. Or, if you know the sine and the cosine of the angle, you can use those too. So the sine of an angle divided by the cosine of an angle is equal to the tangent. Sounds easy enough, right? Now, when we want to find the cosecant of an angle, it is basically the opposite of the sine, which makes it the hypotenuse divided by the side opposite. Or, if you know the sine, just take 1 divided by the sine of the angle, and that will give you the cosecant. As with the cosecant, the secant of an angle is the opposite of the cosine, which makes it the hypotenuse divided by the side adjacent. But, if you know the cosine of the angle, just take 1 divided by the cosine, and that will give you the same answer as you would if you knew the hypotenuse and all of the other sides. And the cotangent of an angle is the same as all of these other ones. It's the side adjacent divided by the side opposite, which makes it the reverse of a regular tangent function. But as is with tangent, if you know the sine and the cosine, then you can calculate the cotangent another way. So, as opposite of the tangent, you will want the cosine of the angle divided by the sine of the angle. Since it's the opposite, you have to do everything in reverse. Now, graphing on the unit circle is fairly simple. Just follow these easy steps. It's just a breeze. It doesn't take long at all. So, when you are first given an angle, let's say 135 degrees, you will draw a curve from 0 on the x-axis and approximate a 135 degree curve. Now this doesn't have to be an exact art, but if you're a perfectionist, just go ahead and take out your protractor, measure 135 degrees, and you'll be set. But otherwise it's just typically an approximation. It's not art. So, once you have your curve, you will draw a line that's connected to your curve and the edge of the unit circle. And this will be the hypotenuse of our right triangle. And then you will then draw a dashed line down to the x-axis. It can be whole if you want, but it's typically dashed to show that it's not actually there, it's just helping us solve the problem. And now you can calculate the measure of the angle on the inside of the triangle. Since 180 degrees is the closest 90-degree angle measure on the axes, you'll subtract 135 from 180 and you'll get 45 degrees. Now you're able to find the sine, cosine, and tangent of the angle. But since we only know the hypotenuse, which is equal to 1 since it's the radius of the unit circle, you're going to want to use your calculator to find the answers. But, as well, you also want to use 135 degrees. You don't want to use 45 because that's just the measure of the triangle. You want to find 135 because that's the true angle that we were originally given. So when you plug it into your calculator, the sine of 135 is the square root of 2 over 2. The cosine of 135 is also the square root of 2 over 2. And the tangent of 135 is negative 1. Now, knowing what we know about triangles and trigonometry, it should be pretty easy to find the basic trigonometric functions for this 3, 4, 5 triangle that I have drawn for you. So, let's find the sine, cosine, and tangent of the angle theta. Since the sine of an angle is the side opposite divided by the hypotenuse, the sine of this particular triangle will be 4 over 5. Now I know that it's wrong here. I wrote 3 over 4 and I don't really know why. So I apologize for my mistake and any inconvenience this may have caused for anyone and or everyone. But moving on. The cosine of an angle is the side adjacent to the angle divided by the hypotenuse. So the cosine of theta will be 3 over 5. And finally, the tangent of theta is the opposite divided by the adjacent side. So it should be 4 over 3. Now using the same 3, 4, 5 triangle, solve for the cosecant, secant, and cotangent of theta. Now the cosecant is the opposite of the sine, which will make it the hypotenuse divided by the side opposite the angle, so it will be 5 over 4. The secant of theta is the opposite of the cosine, which makes it the hypotenuse divided by the side adjacent to the angle, which will make it 5 over 3. And last but not least, the cotangent of theta is the opposite of the tangent, which will make it the side adjacent to the angle divided by the side opposite the angle, which will make it 3 over 4. And I think this probably explains where I got 3 over 4 on the first slide, so apparently I was thinking cotangent instead of sine. I apologize. Now, getting into radian measure. Radians are what we most typically use when measuring angles. They use the symbol pi in these ratios instead of degrees. And some examples are pi over 6, pi over 4, pi over 3, 5 pi over 6, 2 pi, which is 360 degrees when it's converted, but we'll get to that later. And when I say pi, I don't talk about the food that we eat, even though this is a pretty cool pie, because it's a pie. Ah, it's like Inception. But we want the Greek symbol for pi, not the food, the Greek symbol. And when we talk about degrees, it's usually what we use when we measure temperature, but that's not what we want to use it for. We want to use it to find the measure of an angle. And, you know, typical degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, etc., so on and so on. We all know what degrees are. I don't really need to get into that now, do I? I'm sorry, that sounded chastising. I apologize. Now, as I said before, sometimes you'll have to convert radians into degrees. Now, this is pretty simple. So, say for example that you have a radian measure, but you want it to be in degrees. So, you would first multiply the ratio by 180 and then divide it by pi. Now, the two different pi symbols will cancel each other out. So, you will get the equation 5 times 180 all divided by 6, and you should get 150 degrees. Now when you convert between degrees and radians, it's basically the exact opposite. So let's say you have 120 degrees and you want to convert it into radians. You would first multiply it by pi and then divide it by 180. Now since pi ratios keep the symbol pi in the answer, you just want to simplify the equations. So 120 pi over 180 will simplify into 2 pi over 3. Sounds easy enough, right? Now we will calculate the arc length of a given angle. The formula for calculating this is S equals d pi theta all over 360, where S is the arc length we are trying to find, d is the diameter of the circle, or 2 times the radius, and theta is the angle that we are given. Now using this equation, find the arc length of 60 degrees in a circle with a radius equal to 5. So using this formula, first plug in 10 for d, which is 2 times the radius. Since the radius is 5, it's 2 times 5, which equals 10. And theta is equal to 60. Now 10 times 60 is 600 times pi divided by 360. Now we can keep pi in the answer for now, so we can simplify this equation. So 600 divided by 360 is equal to 5 over 3 multiplied by pi. Now you can use 3.14 for pi when you calculate this answer, or you can just go all out and do 5 times the symbol pi on your calculator and then divide that answer by 3. So you should get approximately 5.236. And this has been my presentation. So the only thing I really had to have help with was finding how to calculate the arc length, because I didn't really remember how to do that. But I remember now. So I found out how to do that on this website. And all other information is from my previous pre-calculus experience. I'm a math major, so I should be memorizing this anyway, and it would be pretty bad if I wasn't. And most of my pictures were just found on the PowerPoint clip art, so I don't know if those had to be cited or not, so I did it just in case there was a copyright infringement going on. So now I have them cited so I can't be sued. And the unit circle and all of the triangles were made by me using PowerPoint. At least I know I'm PowerPoint efficient. And the pi inception-ish photo from slide 10 was found on Creative Commons. And the lesson plan I used is given here. I just kind of put it there just in case my teacher needed it. But it's there if you guys want it and you want to know if you're going into pre-calculus what the curriculum is for you to teach for the semester/year. So that's my presentation. I hope you all have a wonderful day, evening, afternoon, whatever time of day it is that you watch this. Good night.